Looks like we're live. Hello everyone and welcome to yet another recreational programming session. Let's make a little bit of an announcement and officially start the stream as usual. Let's do red circle live on Twitch. And what are we doing today on Twitch at a television website? Today we are doing live on GPU. That's what we're doing today. So I'm gonna give the link to https twitch.tv/soding, the place where we're doing all of that, and I'm gonna ping everyone who's interested in being pinged. And there we go, the stream has officially started. So today we're gonna continue working on implementing this paper, which is the generalization of the Conway's Game of Life. As you probably know, Conway's Game of Life is a cellular automaton, but it's a very discrete thing. So this paper is trying to make a smooth generalization, right, on a continuous space instead of a discrete one. And it actually succeeds doing so. So the goal of this paper was to find the omnidirectional glider, as far as I can tell, right? So, and they found it. So in a continuous domain, the glider looks like this, believe it or not, right? So that's how it looks like. Right, and on the previous stream, we implemented this cellular automaton in the terminal, right? So we implemented like a very simple terminal renderer, and it kind of worked. So let's actually take a look at how it looks like. I'm going to just rebuild everything just in case. And if we start up this entire thing, this is how it looks like. So it's a continuous game of life, right? As you can see, it's not like very discrete. It's very sort of like smooth. And that's why it's called Smooth Life, by the way. So this is actually a very stable pattern. What the fuck? Usually the pattern just like spreads out and just finds the stable state. This one actually goes for quite some time. So so usually what it does, it just like goes into this very stable state and just stays there for as long as possible. But for quite some time it may actually just like wander around. Sometimes it may die out completely, right? Sometimes it may die out. Right, so but quite often it just like does these kind of things, and it's actually really cool. As you can see, all of that is in terminal, right? So all of that in terminal, right? And all of that is on CPU. But what I want you to do actually as an ultimate goal is to try doing that thing on GPU. And here's the question, how would you even do something like that on GPU? Right, so to understand how you can do that on GPU, you need to understand how we even compute the next state of this cellular automaton, right? So it's kind of like similar to how we do that with the Conway's Game of Life, right? So essentially for each cell, we are considering the neighborhood of that cell, right? So let me actually start my paint. Right, and based on the state of the neighborhood, we decide whether we want to switch to a dead state or a live state. So in case of the Smooth Game of Life, right, so imagine that this is the sort of like a continuous grid, right, so we have the current point, right, and the state of the point is not 0 and 1 or 1, it's rather from 0 to 1. So what we do, we consider the neighborhood of a certain radius, right, and another neighborhood of a bigger radius, right? So we essentially consider the states of the cell within like inner circle and within the outer circle. And we have a smooth continuous functions that when given the values based on these two neighborhoods gives you the rate at which the state of this point has to change, right? It's like Conway's Game of Life, but it's continuous and smooth, right, instead of like switching between the states. So that's basically what it is, right? And how can you simulate all of that on GPU? Well, you can do a very interesting thing. You can essentially store the state of the cellular automaton in a texture. For instance, if we're going to be doing OpenGL, and we're going to be doing OpenGL, we can store the state in an OpenGL texture, right? So each pixel of the texture represents like the value of the state of the pixel, right? And the next thing we can do, we can come up with a fragment shader that basically, given the texture, renders the next state of this entire stuff. So when the fragment shader actually basically works on the level of pixels. So it's a single program that works on a single pixel of the screen, right? So, and what it will do, it will basically take the texture, take the neighborhood, and then compute the next pixel, right? And in OpenGL, there is such thing as frame buffer of screen rendering. So essentially, you can render not on the screen, but into another texture, right? So essentially you can have a shader, right? So you can have a shader, right, that given a texture will basically compute you the next state as another texture, right? And all of that can happen within a single draw call, right? Within a single draw call, you just give it a texture and then it computes the next texture, right? And so what you can do essentially on the next draw call, you can swap these textures around and repeat that process, right? So essentially with a single shader that for given a texture computes the next texture, you can keep like feeding it into itself and it will keep computing the next state of the cellular automaton on each draw call, right? So at least that's the theory. At least that's the theory. I'm not sure if it's gonna work out in the practice, but as far as I know, people has done it like that on like Shader Toy and stuff like that, and it kind of works, right? But I never implemented that myself, and I really want to implement that myself to understand how you can do this kind of stuff. And it's actually kind of cool, right? Because each pixel can be computed independently. So, and if you manage to put that on GPU, it's going to be extremely parallel. So that means in theory, it's going to be super fast and extremely smooth, right? So imagine like simulating this entire thing at 60 FPS, like very, very smoothly. That would be actually kind of cool, I think, right? That would have been actually kind of cool. So what we're gonna use for doing all of that, right? So obviously, as I already said, that we're gonna use OpenGL. But what I learned is that the library that we use for visualization of the neural networks, right, RayLeap, actually supports custom shaders. Right, so you can not only draw like primitives like circles and rectangles, you can actually customize the shaders with which they can be pre-processed or post-processed and stuff like that. And it also supports the frame buffer off-screen rendering, so it supports a special kind of texture into which you can render scenes. Right, so essentially you can render scene by just rendering it, and then you can switch the mode and it's gonna render the scene into a separate texture that you can then use to render something else, right? Basically frame buffers, right? So it essentially supports, it's built on top of OpenGL, but it actually exposes all of the necessary mechanisms of OpenGL that we might want to use in this sort of simulation. Right, so which makes it actually perfect candidate to use for this project, right? I could have used SDL, but SDL, when it comes to this kind of stuff, it basically serves as a glorified OpenGL initializer and nothing else. And if you need OpenGL initializer, it would be better to use something like GLFW, right? So using SDL as an OpenGL initializer is kind of an overkill in my opinion, right? Of course, it has more stuff for input, output, and sound and stuff like that, but if you just need OpenGL initialization, it's kind of overkill in my opinion. RayLeap, on the other hand, it actually gives you a lot of convenient stuff. It initializes a lot of things and exposes quite a few mechanisms of OpenGL that SDL doesn't expose, right? So, and that's what we're going to be doing today. That's what we're going to be using today. All right, so we got some subs while I was doing the intro. Thank you so much, everyone who just subbed. So we got Donkey Brains. Thank you so much for the Prime. It was 3 hours ago, but I still want to acknowledge that. PhilipPV2, I hope I pronounced your nickname correctly. Thank you so much for tier 1. And Lamexis, I also hope I pronounced your nickname correctly. Thank you so much for Twitch Prime. Thank you, thank you, thank you. All right, let's go. Let's try to implement Smooth live on GPU, right? So I don't really want to remove the existing application in here, right? So I want to create another one that uses RayLeap rendering. So maybe because of that, I'm going to kind of rename this entire thing to something else. Let's actually call it something like Smooth Live term, right? So because it's a terminal, it uses terminal rendering. Right, and in here we probably want to do something like a smooth live term. There we go. So if I rebuild this entire thing, it seems to be working. Okay, so another thing we're gonna do, I'm gonna comment out the previous one, right? And we're going to have something like smooth live GPU, right? So this is a smooth live on GPU. So let's go ahead and create such things. Smooth live GPU.c, right? And I'm gonna include stdio, and let's create an entry point, right? And in here, what we're gonna do, we're going to just print hello world, hello seaman, right? So let's put exclamation mark, And let's try to build that thing as well, and it seems to be working. And let's try to run this entire stuff. GPU, there we go. So let's do the first thing that we usually do, write a simple boilerplate for raylib. Let's include raylib super quick, so raylib. And if I remember correctly, to initialize the window, you have like init window function. I mean, I can just look it up in the source code of raylib itself, right? So there's no need to guess anything. I can just look up init window. Just a second, let me quickly put something behind my camera. I keep forgetting about that for some reason. Just a sec. Good to do it this time. Yes. So init window. So here it is. So here, what we have to specify, width and height and the title, right? So let's actually put something like smooth life in here, smooth life, and let's also provide screen width and screen height. So we're gonna have screen width 800 and screen height, which is gonna be 600. Right? So this is going to be screen width, and this is going to be screen height. There we go. We initialize this entire thing. So if I remember correctly, right, you also have to set the FPS. You have to lock your FPS, set render or something FPS. I don't quite remember. Yeah, set target FPS, right? So we're gonna put 60 FPS because I mean it's 2023. I think we can afford having 60 FPS per second. Frames FPS per second. Right, I think it is actually quite affordable these days. Okay, so and after that, that is basically, this is the entire initialization of the library, right? So the entire initialization, the only thing you need to do, you need to organize the event loop, right? So as far as I know, for that there was a function should, yeah, window should close. It basically, I presume, flashes all of the events, all of the input events and stuff like that, handles everything and stuff like that, and then answers the question whether the window should close soon. Right, and while the window should not close yet, we're gonna keep processing those things. And how we're gonna be processing that? We can just render something, begin drawing. We start drawing. Here we can clear the background with, let's say, a red color. I want something bright, so it's instantly visible that we are doing something on the screen. And then we just end the drawing, and that is it. This is the entire boilerplate of raylib. Right, so that's why it's so freaking cool, right? Or every function call just like makes sense, and there's nothing, you know, there's no redundancy in here. That's basically what you want to have in here. Yes. Right, so, and of course it's not going to work because it cannot find raylib. This library does not exist. I just made it up. This magical library that was talking about, it doesn't exist. It's fake. I just made that up. Things cannot be that good in 2023. If you want to put something on the screen in 2023, you have to fucking suffer. I'm actually joking. So we just need to set up some things, some flags specifically. Right, so right, we're gonna use package config. Right, so essentially it's gonna be package config, and we're gonna use raylib and basically asking, give us the flags that we need to pass to the compiler for raylib to work. Right, so these are the flags. Right, these are the flags. And also we can ask for the libraries to link with. Right, so this is gonna be libs. Alright, so, and let's try to recompile. It still doesn't work because it cannot find the package configuration. So we have to set up the environment properly. So I have a raylib environment somewhere here, and that should finally work. As you can see, it compiled, but it didn't freaking link. I think you should also put close window. Yeah, I also think so, but I wonder if the application just exits, it will just work, right? Well, we'll see. All right, so as you can see, it also wants to link with things that start with DL, things like DL open, DL close, DL sim. And as far as I know, these names are available in library DL, so we can link with LDL, right? So another thing it wants to have GLFW, surprisingly. Okay, so let's link that with the GLFW. Right, it uses GLFW for initialization, and the last thing it wants is p-threads, right? So let's provide p-threads as well, and there you go. As easy as that. As easy as that. And when I close it, everything's fine. As you can see, I didn't really even have to like call close window because it works without it, right? But to maybe keep things clean, we can try to do that. Close window. Here it is. So maybe this is something that we have to call at the end of the application, even though, as we observed, it doesn't really make much difference. I suppose it just cleans things up, maybe deallocates some memory and stuff like that. But as you know, in the modern operating system just cleans up everything after you. Unless it's trying to do something that operating system is not aware of. Maybe it needs to modify something on the hard drive or something, I don't know. Right, but let's have a close window here just in case. There we go, pretty cool. Pretty freaking cool. So now we need to work with textures, right? So now we need to work with textures. So if I remember correctly, how do we even create and render the texture? So let me find, let's actually try to render a texture on the screen, right? So let's just try to render the texture on the screen. Let's not go too crazy very quickly, right? So texture, as far as I know, there is a draw texture. Yeah, there we go. So there is a draw texture. So it accepts texture 2D. So we need to construct texture 2D somehow. Right, let's try to find how we can do that. So here's the texture 2D, nothing particularly interesting for us. Oh yeah, this one is very interesting. So it has a special kind of texture called render texture 2D, right? So it just has a texture 2D and render texture 2D. So the thing about render texture 2D is that it's the texture into which you can render things. It's a render target, right? So, and this is like a perfect candidate for our case, right? So essentially, if we store the state in a texture, we compute the next state into another texture, into the render target. Right, that we can then use for the next sort of iteration and the next iteration and the next iteration. Right. So let me see, but we're not gonna go into that yet. Texture 2D. So let's find load texture, right? So you can actually load texture from a file. But this is not really what I want, because I want to be able to actually initialize the pixels myself, right? So the thing that we're probably going to use, we're going to use texture from image, right? So an image is like a texture, but on CPU, right? If I'm not mistaken. So load texture, so this is the texture, but where can we get an image, right? Where can we get an image? That's a very interesting question. Where can we get an image? So as far as I know, there was something like load image, right? So you can load image from the file, but this is not what we want. And also, if I remember correctly, you could generate some, yeah, you could generate an image, right? So you can generate like a solid color thing. And also it allows you to generate some patterns, right? So that's actually kind of cool, right? So you can generate some pattern. You can generate the Perlin noise. Is that how we pronounce that? Perlin noise? Perlin? I think that's how we pronounce that. Let's try to generate some Perlin noise. This is actually super convenient. So what's going to be the size of the texture? So I think the size of the texture is going to be the size of the window, right? So because the size of the window is going to be the you know, the whole area within which we're simulating the smooth game of life, right? So that makes sense in my opinion. So this is a screen width and screen height. So I have no idea what is offset X and offset Y. As far as I know, Perlin noise is just like an infinite plane, and I suppose that's basically the offset within that plane. So I suppose I can put just 0 in here. And I don't know what is a scale, but since scale is usually something you multiply by, just in case I want to put a 1 in here, so it does not, multiplication does not end up with 0 or something like that, right? So this is purely my intuition, right? I'm going off of the intuition. I don't really know what exactly all of these parameters mean, right? Welcome to software development, by the way. Welcome to software development. Okay, so we have some texture. Can I just draw the texture? Draw texture. Yeah, I can draw the texture. So let's actually put it somewhere. Right, so here we're cleaning up with the clean stuff. So maybe I'm going to put black in here, right? So then I'm going to put the texture in here. We're going to render it at 0. And tint is going to be white. So as far as I know, tint is just like adds additional like color component to the whole texture. Tint, it just adds the tint to the texture, right? So in our case, like we put white, so that means there will be no tint, it's going to be original color of the texture, if I understood correctly. Right, so let's try to run this into, I think, and see if it's going to, there we go, that's a Perlin noise. Right, it may look like clouds, and yes, Perlin noise quite often is used to simulate clouds, right, quite often. Also, it's, I heard it's also used for generating terrains, right? As far as I know, Minecraft uses, or at least used to use, Perlin noise for generating terrains and stuff like that. Or maybe it still uses, because like, what do you replace it with? Right, so let's actually play with different parameters in here. So what if I make it like bigger? What if I make 5 in here? So I suppose it's going to be more dense. So I presume it just like sort of zooms out, maybe. Or maybe it's going to zoom in. Sometimes it's kind of difficult to tell what exactly this entire thing is going to do. No, it zoomed out. Right, it kind of zoomed out, so it made it a little bit more dense. We can take a look at some other patterns in here, right? So generate Perlin, again, image. So there's also white noise. Generate cellular algorithm. Oh, this one is interesting. Okay. So what is this thingy-majingy? So we can provide screen width. So screen width and screen height and tile size. Let's actually set the tile size is going to be maybe 1/6 of the width or something like that. I don't know if it's go. Is that a It's a Voronoi diagram. Yo, it's actually kind of cool. All right, what if I make it smaller? Right, so let's actually try to make it smaller. Yeah, it gives me trypophobia, to be fair. What the fuck? Raysan, what the fuck? Why do you have trypophobia in your library? Alright, so let's actually use Perlin noise. I think Perlin noise is a little bit better. What the fuck? So this one is actually kind of cool because we can use this already as the initial state of the smooth life, right? Because yeah, that's the perfect state. So maybe we can take a look at the like white noise, right? So let's take a look at white noise. So because I remember seeing white noise in here. So I don't know what is a factor, but I'm gonna just set it to 1, right? Screen width and screen height. There we go. So let me see, and that's, well, I mean, it's white, but is it really noise? Maybe we need to increase the value of this entire thing? No? What about 10? Maybe it has to be like less than 1? Is that what you want? Oh yeah, it wants less than, okay, so it just wanted it less than 1, okay, sure. Right, so the bigger the value, the denser it becomes, I suppose. Right, so, and this also could be like initial state. As far as I know, it is recommended to initialize the board with the white noise. I really apologize for the encoding right now. The encoding is probably horrible because of the white noise. Right, it is really recommended to initialize smooth life with just a random state. Right, but has anyone tried like a Perlin noise? I think Perlin noise is a way better way of initializing this stuff. It also takes some time to initialize, so there is initial delay. Yeah, you can clearly see the initial delay before it like generated this thing. Yeah, it causes strange encoding. Yeah, this is because it's a white noise. It's pretty normal for encoders to freak out when there's a lot of small little details. I don't really know how encoders work, but I assume that they essentially send a lot of deltas of the image, right? So they never like send over the network the whole image because that's a lot of information. They probably send deltas, right? And also a compression algo. Okay, so maybe it's bad for the compression algo. So I thought maybe like a lot of small changes like causes a lot of change on the screen or something like that. But if it's a compression algo, actually the problem with compression algo makes a lot of sense, because if there's a lot of noise, it's kind of difficult to compress, so it just like drops down the quality or something. I don't know. So maybe I should learn about encoders. Right. So we got some subs. Thank you so much, Copper Cased, for tier 1 subscription. 45 months of tier 1 subscription with the message Tsodin Weeb. Hello, Tsodin in chat. Hello, hello. Thank you so much for the sub. Thank you so much for the sub. All right, so can we write a shader that has an access to this entire thing? So that's an interesting question, right? So we can draw a texture, but how can we customize a shader that renders that texture? Because obviously RayLib probably used some sort of a shader to render this texture. In OpenGL, you can't render shit without the shader, right? So we need to be able to customize that. So as far as I know, in RayLib, you can literally create a shader. So there are shaders. Yeah, so here is the structure. I wonder if there's something like load shader. Yeah, there we go. So, and you have to load vertex and fragment shader. Is that really necessary? Man, like, I don't really care about vertex shader. Can I tell this entire thing is just like, use the default vertex shader? And just like I'm gonna replace only the fragment shader. You know what? As far as I know, this thing has a lot of examples. So let's take a look at the examples. Right. So here are the examples. There's a shit ton of them, right? Android and web. Wait a second. This thing works on Android and web. So that means I can take whatever I developed for neural network visualization and port it to the browsers for everyone to play. That's actually perfect. Topic for the next stream, question mark? Yo! Right, so the thing that we have in neural networks in here, so NN.H, right? So the UI that allows you to train and stuff like that. If we manage to port that thing to web, that would be perfect for promotion and stuff like that, because it's super easy to give to people, look guys, this is what I'm doing, and they can instantly just play with this thing, and they can just see that you can just like train this stuff. It's just like, actually, I should give it a try. Right, so maybe the next stream on neural networks is going to be actually porting this shit to web, right? So people can play with this thing on the web without trying to build it. And that's perfect, actually. What the fuck? And since the NN.H is such a simple library, I don't see any reason for NN.H to actually not work in WebAssembly, right? Because it depends a little bit on libc, but not too much. Yo, that would be perfect. Anyway. So, but that's not the topic of today's stream. All right, so let's go. So I want you to take a look at the examples, right? So I want you to take a look at the examples, and let's actually literally grab. Does anyone use load shader? Right, load shader. Okay, so only one, I suppose. Maybe we have to do shaders. Yeah, it was shader. That's weird. So there is a version. Oh, okay. So I'm looking. It accepts only one parameter, but they just split it on two separate lines. Okay. Oh, look at that. Okay, so this is actually kind of cool. So you don't have to provide both of the shaders. Okay, so that's actually kind of cool. I can only provide the fragment shaders and stuff like that. That's actually kind of cool. All right. So I wonder for the textures. Do we have some shaders in here? Right, so let me take a look. Okay, so when we're talking about shaders, the textures, they don't really do anything. What if we go into the shaders and search for load texture? Okay, so let me see custom shader shapes. Okay, this one is interesting. So you're loading a thing. Okay, this is precisely what I want. This is actually our case. So here we're loading a texture, and then we're loading a shader that is only fragment shader, right? The only fragment shader. So I suppose it just modifies the texture. Okay, so this is actually kind of cool. Oh yeah. So essentially, they supply different shaders for different versions of GLSL, right? So in resources, they have shaders, and yeah, so as you can see, there's like 3 folders in here, and depending on the macro that we have in here, it's going to be how this macro is even decided. This is actually a very interesting question, right? If I take a look at the RayLib, how is it decided? GLSL is probably located in RLJL. No, GLSL version. Okay, so it's not even okay. Grep GLSL version. So it's probably coming from the OpenGL, right? So from the OpenGL headers. So that's probably where it's coming from. Or maybe it's defined in the examples themselves. Is it defined in the... It is defined in the examples themselves, and... Ooh. Yo. So if the platform is desktop, on a desktop it uses the 3.3, on the RPI, so I suppose it's a Raspberry Pi, Android, and web. Yo. This is the nerdiest shit I've ever seen. Yo, what the fuck? This is so cool. Right. So... all of the platforms the nerds will like basically port their stuff to. So cool. Unfortunately, I don't really have RPI, right? It would be kind of nice to have Raspberry Pi, but I'm too poor for this kind of shit. So, all right. So I suppose we're going to be using the version 3.3, right? So that kind of makes sense. Okay, and let me take a look at the shader itself, right? So let me take a look at the shader. So that means you need multiple shaders. I guess we can't implement that. I guess that's basically unsolved computer science problem. It's impossible to have several shaders for different platforms. It's just like, I guess we have to give up. Only multi-billion corporation company can afford such a complicated project. Okay, so let's take a look at this thing. And grayscale. Okay, so this is what we have in here. GLSL mode. So input vertex attributes from the vertex shaders, so it gives you frag text coordinate. I suppose this is the coordinate of the texture, right? So and it's probably specific to the default vertex shader, right? And this is the input frag color. We can also have the uniform textures, and I suppose I wonder if all of that stuff is just like hard-coded, right? So there's also cold diffuse. And output colors, so this is where we compute the output color too. And frag text coord is actually already normalized. So it's already normalized because we are directly feeding it into the texture function. Right. Okay. So, and frag color, like having frag color is actually very useful because it's the current color of the fragment thingy, right? So that, well, not really. It could be the color, it could be the tint actually. This mother flipper could be the tint. Yo, we'll need to double check that, right? So, and there's like different conversions in here, but I mean, I don't really care. Okay, so this is actually perfect. This is exactly what I wanted. Okay, so let's go ahead and create our own shader. So smooth life, and it's gonna be a fragment shader, so it's gonna be FS version. I'm gonna actually so GLSL mode, so 3.0, and I'm gonna start copy pasting the code from here. So I suppose I'm gonna literally copy paste all of these things in here, right? So I presume this is the stuff that's coming from the library itself, right? So the library itself supplies all these inputs and uniforms, and outputs are expected to be like that. So I better just copy paste this stuff like as it is, right? So, and then let's actually do the following thing, right? Let's do the following thing. Here, I'm gonna take the final color, right? So here we just like modify the stuff and we set the final color, but I'm gonna do the outrageous thing. I'm gonna set the final color to, let's say, green, right? So something really bright that we didn't use before, right? So before we used the red, but now I'm gonna set it to green. So no matter what kind of texture we have in here, it's gonna be always green, and that means we kind of control this entire thing, right? Okay, and that's basically the whole shader, right? So let me go to GPU and let's try to load that shader, right? So load shader, let me go to Raylib in here. Load shader, and I'm gonna like literally copy paste it in here, I think, because I want to have the actual signature, right? So this is our shader. We're not gonna provide the vertex shader. We don't really care about the vertex shader in today's project, at least. And in here we're gonna supply smooth live.fs, and that should just work. So the question is, how do we even use such shader, right? So shader shapes texture, right? So shader, okay, so you have to use begin shader mode. That makes sense, actually. That's actually kind of cool. So you begin drawing, you draw some stuff, and then you want to switch the current shader. You begin the shader mode, you render within that shader mode, and you end it. You can actually have like a several shaders, right? And you can switch between them. and stuff like that. So that's kind of cool. That's precisely what we're gonna do. So, all right, can I do something like this? 1, 2, 3, 4, and then begin shader mode. Just use this shader, render the texture with that specific shader, and we're gonna end the shader mode, and let's see if it's gonna work. If everything went according to the plan, we're gonna see the green screen, just like the entire screen is supposed to be green. Let's go ahead and do that. So can I do that? It didn't work the way I expected this entire thing to work, so that's kind of weird. So something went wrong, so I can already see the warnings in here. Failed to compile the fragment shader. Okay, so that's actually kind of cool. Too many parameters for vector 2. All right, so it's 16. It has to be vector 4, of course. Thank you so much. And there we go. So it worked. It actually worked. So we can take the color green and we can essentially take the texture, right? Texture 0, and we can multiply it by the current like pixel, right? So this is the fragment texture color, right? So, and that means it's going to be Perlin noise, but it's going to be greenish Perlin noise, if you know what I mean, right? So it's going to be more of a greenish one now, and it's a greenish Perlin noise, right? So we have custom shaders. Those are some useful error messages. As far as I know, they're coming from the OpenGL itself, right? It's not like Raylib shows them. Raylib just basically proxies whatever OpenGL told it, right? So yeah. So it's more of a, like, I suppose, achievement of Mesa, but I mean, Raylib is also pretty cool library as well. Right. So, and I'm wondering what is a frag color, right? So what if I just say, okay, the final color is the frag color. If I understand correctly, this might be the tint. This might be the tint. So that means if I just do something like that, it's going to be completely white, right? Because I set the tint to be white. Yep, I was right. So I can modify that specific thing in here from here. So let's actually set it to blue. So this is the color that we never used before. Before we used red, green, and now blue, just to distinguish, right? So different stuff. There we go. So that's a very interesting blue. I don't think it's a pure blue. I suppose it's a Raylib blue, right? So okay, so if I go to Raylib, let me find defined blue. Yeah, it's not a pure blue. Look, it's just so funny. I remember, like, somebody commented on the YouTube video about Raylib is that everyone is trying to have like a prefix to not pollute the namespace, and Chad Raylib being like, define red. Fuck your namespaces. Fuck your namespaces. Define red. You don't need that name. This is my name. Right. Why would you need that name for? Like, I mean, you're obviously using Raylib, so you're obviously gonna only define this as the color red for Raylib. Obviously. So, right. This is how Chad libraries define their names. None of that virgin prefixes, namespaces. Define red. You don't need other libraries. That's it. You don't need other libraries. Alright. Oh, to be fair, that's a good point. You can actually undefine it, right? So I didn't think about that. So for things like that, yeah, I suppose it makes sense, because at any point you can just undefine it and it's not that critical. So yeah, I see. I'm actually joking. I'm like, I don't consider that to be like an actual criticism or like showstopper to use this library. I just find it funny a little bit. Right. Raylib be like, namespace your own code. Yeah, exactly. It's not the Raylib who needs to namespace their names, it's you. Right. Alright. Okay, so let's continue. So we have this kind of stuff, and it seems to be working. So we can already try to port this entire thing to, yeah, that's like everything, but we need to be able to, I guess, render things into render texture, right? So we'll need to compute the next state somewhere, right? So let me see, how do you define render texture 2D, right? So can you just do, okay, load render texture. So you can load this thing from just width. You can allocate some width in here. Load render texture. Is that it? But what if I want to construct a render texture out of this texture? How do you even fucking do that? So that's really strange. Okay, so let me take a look at the definition of this thing. Where was the definition? Okay, so it's a type def for render texture. Okay, sure. And within this thing, it has two textures. And the texture, it's actually, okay, so the texture and texture 2D are the same thing. Why? Oh, this, okay. Maybe this is some sort of like a backward compatibility thing, I don't know why, but texture 2D and texture is the same thing, as well as render texture 2D and render texture. Okay, sure. So I suppose, so there's also depth buffer attached to it. That's kind of cool. So yeah, if we can access the texture, one of the things we can do, can we create a render texture? Right, so let me try to do that. So render texture, load render texture. So there is no such thing like as load render texture from image. Let me double check that. I'm gonna try to recompile. Yeah, there is no such thing. So we can also only load render texture by its size, right? So we can only just pre-allocate it. But now we need to somehow get the pixels of the render texture into pixels of this image into this render texture somehow. So this is a really weird API, not gonna lie. So, and I suppose the way we can do that, so here I can just access the original picture, yeah, texture. I mean, that's fine if I take a look at the Smooth Life FS. So let me just go back. So this entire thing has to be black. Yeah, okay. So I suppose since this is a render texture, but I still can access the texture like a raw texture 2D, I should be able to use something like maybe update texture. Right, yeah, update texture, which I can provide, to which I can provide the pixels. I can actually do something like that. Yeah, there we go. That's a really weird way of doing that, but I mean, then I can just use image data. So that should work out, and it worked. Okay, so it's a really weird hoops that you have to go through. It would be kind of nice if like you had the same interface for working with render textures as you have with just textures, right? But I mean, that works out too. I mean, why not? It's just like a little bit weird. Okay, so we can think about this thing as sort of like a state 0, right? So this is original state of the like initial state of the game, right? So this is the initial state of the game, and then we can have something like state 1, and state 1 is basically the state into which we are rendering this entire thing, right? So into which we are rendering this entire thing. So let me see. So as far as I know, you have to do begin texture. Yeah, begin texture mode, right? So as you can see here, you provide the texture. So essentially, you have to provide the texture here into which you want to render shit. Let me take a look at some examples that maybe explain how you use this entire thing, right? So do we have anything in here? Fog of War. There's literally an example called Fog of War. This is actually pretty cool. Right, so you start rendering and you just literally render it as you would render anything, but it's not going to be displayed. It's going to be basically rendered into this texture. And then you can just render this texture on top of something, for instance. So this is actually very cool. This is precisely what we want, right? So you can have basically two-stage rendering. Right, so we can render one thing into the texture and then use that texture to render something else. And as far as I can understand, you can have like several sort of steps of rendering through this like frame buffers and render textures and stuff like that. So here is the first phase where this example, I suppose, generates Fog of War, right? And then that generated Fog of War is used in the main rendering that is going to be displayed. And that's literally our case, right? So in here, right, so where's the GPU? So here's the actual rendering, but maybe we want to actually render state 1, right? And we want to do something like begin texture mode, and we render into state 1, right? So and then end texture mode. And what we're going to be doing in here, I suppose we're going to be cleaning everything up, right? So we're cleaning everything up, and we're rendering the previous texture. Yeah. So as you can see here, we're rendering state 0 into state 1, right? And then we're rendering state 1 onto the screen, right? So, and then the next thing we can do, we can swap those texture around somehow. I don't really know how we can swap them. Are they like very, you know, heavy structures? I don't think they're very heavy structures. Right, so this is the entire structure. It contains another structure, which is texture, which is just a bunch of numbers. So I should be able to literally like copy them, right? Can I do something like that? State 0, right? So then I can replace state 0 with state 1, and then state 1 with T. So like I directly describe what I want you to describe, right? So essentially, we don't even... Okay, so for this one, by the way, we don't need the shader, actually. Right, since we just want to display the texture, we don't need the shader. Yeah, so the shader is needed to compute the next thing. Yo. Okay, so that makes sense. So that's the whole logic, right? So that's the whole logic. So does it make sense? I think it makes sense. That's actually kind of cool. How is it going to work, actually? So let's not swap things around. Let's not swap things around. I wonder how it is going to just like do things. Let me see. It doesn't even compile because it's supposed to be state 0. All right. Okay. So I wonder if it's gonna. We can do a pretty cool shit. Right, for instance, we can already animate things within fragment shaders, right? So essentially, I multiply this thing by 1, but what if I do by 0.999? So it's not only gonna make it green, it's gonna make it slightly dimmer. And then on the next iteration, it's gonna make it slightly dimmer and dimmer and dimmer, and it will effectively animate this entire thing. Right, because the previous frame fed into the next frame. So they form sort of like a feedback loop. So by doing that, it will basically like fade it out. And that will confirm that we have like an actual algorithm that we can use for the cellular automaton. This is actually pretty progress, my friends. This is pretty progress, my friends. So let's go ahead and do that. Well, I mean, we have to enable the, you know, the swapping of the states and stuff like that, right? That looks like shit. Why is it tearing? But I mean, okay, that's fine, but it's not supposed to tear. Do you see the tearing, or is that the one? No, you don't see that. Or did you see that? That is so weird. Do you see anything weird? You see, okay, so let me... Okay, on OBS, it doesn't really show on OBS. Sometimes it just swaps. So sometimes it just swaps out, but I'm not really sure what the hell is going on. So that's really weird. Okay, so so that means it's something with my machine then. Okay, that's very interesting. Okay, doesn't happen every time. Yeah, and sometimes it just like completely swaps out or something. It's just so weird, bro. This time it was all right. Huh. I wonder if it's okay. Maybe we can try to use some image. Maybe we can try to use some image. So let me try to take a look at Rayleigh.h. What do we have in there? So gen Perlin gen image. Not get image, gen image. Perlin noise. So gradient radio checked. So I suppose it's cellular. Let's try cellular. I just want to confirm that this is not some sort of a bug in my code, because I don't think it's a bug in my code. My code is actually super simple. Right. So tile size, let's say, is going to be maybe screen height this time, divided by 6. Right, so let's actually keep it like that. Okay. Okay, it's super smooth. So what's important is that it's smooth on your side. Instead of swapping, you just put contents of state 0 to state 1. How do you put the content of state 0 into state 1? So that's the real question. How do you put the content of one thing to another thing? Like, I don't know. So instead of swapping, by the way, we can actually do something like render state 2. How about that? So then we can just do it like that. There we go. And then here we're gonna just have 0, right? So we initialize this thing with 0, and then we can have something like size ti, right? So there is a very interesting trick that maybe young developers don't know, but if you have like I that you basically wanna flip-flop between 0 and 1, one of the things you can do essentially is do I equal 1 minus I, right? So pause and ponder on this specific expression, right? So if I is equal to 0, this entire operation will turn I into 1. If I is equal to 1, 1 minus 1 is going to be 0. And as you can see, it loops around, so it allows you to actually flip-flop between 0 and 1. Right, so this is actually a very convenient sort of like a trick, right? If you never heard about it, so now you know, right? Isn't it obvious? For some people, it's not obvious. It was not obvious for me as well. So yeah, feel free to feel good about yourself. All right. So, and the thing we can do now, right, we can basically say, okay, use an opposite one to render into the current one, right? So this is the opposite one and render into the current one, right? And then we are rendering the opposite one, right? So that's basically what we do. And now to switch between them, you just do I minus 1, right? So you don't copy the texture if you don't really want to copy the texture. So you can also probably maybe use like pointers, but I mean, yeah. So that allows you to basically flip-flop between these two things. Effectively. Not sure if it's worth it, right? I'm not sure if it's worth it, but it's something that you can do, I suppose. And so this is the state. Well, we have to probably remove this entire thing. That's all right. That's all right. Okay. So, and you can effectively think about I as the pointer, right? So, and you just like swap in between these two things. Okay, I think the time has fucking come to try to port our code to the thing, right? So let's take a look at our code, right? Let's take a look at our code, where it is, where is it? So maybe I'm already streaming for 1 hour and I ran out of tea. You know what that means, chat? You know what that means, chat? That means we need to make a small break, right? So a little bit of a tea time wouldn't hurt. So, alright, so let's go. Ooh. So how are we gonna actually port this entire thing? So here, the main sort of algorithm of Smooth Live is compute grid diff, right? So in here, we're iterating each individual pixel of the grid, right? But the main difference from the GPU is that this kind of outer loop is done by the GPU for us. Not really by the GPU, but at least by the graphical library, right? So when you're writing a shader, right, you're writing a program for a single pixel. That's quite important to remember. You're writing a program for a single pixel. Right, so essentially that means that we don't need this outer loop, but we do need everything within that loop, right? So basically looking at the current pixel and just looking at the neighborhood, right? So essentially this is the fragment shader. right? So this is what it means to write fragment shader, right? So, and this is sort of one of the paradigm shifts that you have to mentally do when you start doing like a GPU programming, is that you don't program directly into things anymore. You program like for like small batches of data, and the GPU parallelizes your program into many batches and stuff like that. So you have to think in a more of a parallel paradigm now, right? So that's basically what you have to do. So I literally copy pasted it. I don't know like whether it's gonna work or not. So let's actually go through this entire stuff. Right. We don't have a grid anymore, right? We don't have a grid anymore. And it's more of a grid now is the texture, right? So grid now is the texture. So that's what it is. And another interesting thing is that here we are iterating from 0 to width, and we measure everything in pixels, right? But the problem here is that here we measure everything in normalized texture coordinates, and normalized texture coordinates are from 0 to 1. So this kind of iteration is just simply not going to work. So what I'm thinking is that we need to know the resolution of the screen in the shader somehow, right? We need to know it. How can we even know it? I suppose we need to pass it somehow, right? So as you can see, we can have uniform, we can introduce some sort of a uniform vector too called resolution, right? And we can ask the host program to just pass the current size of the window there, so we can then basically scale everything according to the resolution and just at least understand what the hell is going on, right? So let's actually go ahead and try to do that. So I think it's going to be rather interesting. So I'm gonna just basically do something like this. Yes, you can have a preprocessor in the shaders, by the way, right? You do have preprocessor, you can do defines, I think. I don't know if you can do includes. Well, I mean, my mode of Emacs actually highlights that you can do include, but yeah. But you can do defines, you can have conditional compilation and stuff like that, so which is useful sometimes, I suppose. All right, so we want to pass the resolution, but the question is, how do we do uniforms in here? Let me see. So I'm gonna go into the examples, and let's maybe query something for uniforms. But I don't really know what functions do you use for uniforms. Uniform. Is there any stuff? Okay, so. Example, there was a shader. Do you have any uniforms in here? Do we have any uniforms? So the shader that we pass in here, by the way, so there's no shader in here. God damn it. Okay, so what kind of shaders do we have in here? Load shader. All right, so grayscale. Do we have a grayscale? Do we have additional uniforms in here? I don't think so. Call diffuse. Let me go through some of this stuff in here. So maybe I'm gonna go in here. GLSL. Okay. Okay, we don't have a custom things in here. Color mix. Okay, so this one looks like a custom uniform. Right, divider. So that means it should be possible within the example to find the following combination of characters. Double quote, divider, double quote. And that will tell us what kind of functions do you... Okay, get shader... Okay, that's precisely what I want you to find. So it's kind of similar to functions like GL, get shader location, but it's just like without GL prefix. Okay, so that's cool. All right, so we have some examples. So we... Yeah, okay. Okay, so attributes, that makes sense. And then when you have a location, you set it with a set shader, you provide the pointer, and then you specify what kind of type you have in here. So that means set shader value accepts void pointer. Yes, it does accept void. Okay, so that makes a lot of sense. Like, you see, you don't need a very sophisticated documentation. You just need like a simple example. And as soon as you have a simple example, you can just like, you know, work off of that example and like derive the rest of the knowledge, right? So just a simple, like a just simple line of an example, and that's it. You can derive all the knowledge from there. Okay, so that's pretty cool. So let's go divider lock, get shader location. So smooth. A GPU. So what kind of location do we need to find? So we compiled the shader in here, get shader location, So this is the shader, and we can provide the resolution. So here's the resolution. So the type of the shader location is integer. So this is going to be integer resolution lock. There we go. So and in here we can just set everything. Set shader value. And we probably have to supply vector2 in here, right? I wonder what kind. Yeah, so vector2 and vector3, and we do have things like vector2, right? So that means I need to put the resolution somewhere here, right? So vector2 resolution, and we're gonna put screen width and screen height in there, and there we go. We've got our vector. Set shader value. So here is the set shader value. And what do we set in here? So we set shader. What is the other thing? Resolution location. I can actually split the screen into two so I can see stuff. Resolution location. And then pointed to the resolution shader uniform vec2, but it's not ivec, it's a vec2 just. There we go. Cool. So I suppose we only need to set it once, right? So because we're not going to be changing resolution yet. Maybe in the future we will, but just enabling the resizing of the window, I don't think it's going to be enough, because every time you resize the window, you also need to resize the textures within which you're rendering everything. So it's a little bit of a machinery that you build, that you need to build on top of this entire thing, and because of that, I just don't want to do it right now. Okay, so we've got our resolution, so I'm gonna assume that we do have a resolution in there now, but I don't have a way to confirm that yet at all, right? So I really don't have a way to confirm that it actually works. So I wonder, how can we confirm that we got the resolution, right? So how can we confirm that? So fs, let me go in here. So essentially we probably have something like gl frag coord, and these are the coordinates of the fragment, and as far as I know, they are in screen coordinates. They are not normalized. So if I try to do the UV mango, right? So essentially the gradient of you know, red and green, so it turns into this sort of like a mango-ish color. I won't be able to do it with frag colors, frag coordinates, because they're too big, right? If I try to do something like vector4 gl frag coordinate y 0 1, it's not going to work per se. I think it's going to be like literally white, and it's more of a green actually, right? So which is rather weird, right? So if I put 0 in here, right, so this is weird. This is straight up weird. GL frag y. Huh. This is absolutely weird. Why it doesn't work? So what GL frag actually means in here? So if we just use the frag coord, right? The frag coord, what is the frag text coord, right? So frag text coord, x, y, it's gonna be a mango. It's not a mango. Huh. What the hell? Am I missing something, chat? Am I missing something? Why this doesn't work? It's only the green, and what if I put 0 in here? XZ plane, maybe? Why would it be XZ plane? That doesn't make any sense. And on top of that, why did it just work? So, okay, we have mismatched. Oh, all right. Swizzle Mask Z, it didn't even work properly. Alright. So I wonder if this is because there was some warnings in here. This is so weird. Why? This is a mystery. Because we just did that and it worked, but it doesn't work anymore. So do I have to go back or something? I can try to go back. So here we just do that. So there's also tint here, blue, which I don't really care about, right? So this is just gonna be white. I wonder if it's changing anything. It works. Wait a freaking second. Was that because of the tint? Was the tint messing up the coordinates as well? That doesn't make any sense because I ignored the tint, didn't I? No. Oh, okay. Okay, that makes sense. I see what was wrong. Since I don't set my custom shader on this rendering, their shader was actually messing up with the tint. Okay, that explains everything. I freaked out for a second. Right, so in here we do control the tint. We can just disable the tint from the shader. But as soon as we go here, we have zero control over the thing, so it's the territory of the default shaders. Alright, this is actually very important. Right, so the reason to understand precisely what's going on is very important because shaders are really hard to debug. If there is even slight confusion, you better like spend extra time understanding what the hell is going on, because if it's gonna fuck you later, you won't be able to understand why. Hard aka impossible. Yeah, so if something weird going on, just drill down to that and understand why exactly that happening. Otherwise it's gonna be a disaster. You need to understand literally everything because it's so hard to debug. RenderDoc sometimes helps, yes, so maybe this is something that we're gonna employ today. We'll see. Doing this kind of shit is actually super scary. Right. So dumb question, what is shader really? So it's a program that runs on GPU. That's literally basically what shader is. So you write a program in C, it runs on your CPU. Right, so to run program on GPU, what you have to do, you have to write that program in a shader language, in one of the shader languages like JLSL or HLSL. Then usually your C program has to take the source code of your shader program using the API calls of the graphic libraries like DirectX or OpenGL or Metal. You have to compile the source code of that shader and then upload it to GPU. For all of these actions, there are functions in the graphical library, and then you will be able to run this thing on GPU. So essentially how graphical applications work. They start on the CPU, then they prepare the programs that they want to run on GPU, they upload it on GPU, right, and they're running on GPU and CPU simultaneously, and they sort of like synchronize with each other and they interact with each other. So that's basically how it works. So shader, basically, roughly speaking, is a program that runs on your GPU as an opposite of running on CPU. So that's basically what it is. So these days there are some sort of like ideas that you first pre-compile your shaders into this intermediate language called SPIR-V, and instead of compiling it in the runtime, you just load that bytecode of that SPIR-V and you just give it to the graphics library, so there's no compilation step in the runtime, right? There's usually a compilation step in the compile time or something like that, but basically it's a program that runs on your GPU. So that's how you can think of it. Let's continue. So what do we have in here? So okay, so what I want you to do, I want you to actually use GL frag chord, right? GL frag chord is going to be X, GL frag chord Y, right? And if I try to run this entire thing, this becomes yellows because this thing is so huge. There's some line. Oh, okay. This is actually pretty cool. So you can see that there is one line pixel red and one line pixel green, and this is because the size of GL chord is in the size of the it's in the screen coordinates. That's what I'm trying to say. right? It's in the screen coordinates, but what we want here, we want actually normalized coordinates. So if we passed the resolution correctly, just by dividing by the resolution, we will be able to normalize it back to 0 to 1, right? If we did everything correctly, that's a correct Mango. This is a straight up correct Mango. Moreover, for some reason, it feels like this is not OpenGL coordinates. What the fuck? Wait a second. The black has to be here. In OpenGL, does RayLib inverts the vertical thing to have like non-OpenGL coordinates or something? I think that's what it does, yeah. So I suppose the RayLib messes up the coordinates and stuff like that. Right. For those who doesn't know, this is what I call you know, UV Mango. Right. So this is what I call UV Mango. Right. It's essentially when you take UV coordinates and you plug X into red and Y into green, and you end up with this gradient that looks like a mango. Right. So that's what it is. Okay. So, and if we disable setting the value of the resolution, that will not work. That will be just black screen, or it's actually rather interesting. So unused resolution. So I suppose we just had the garbage in there, right? So I would expect this thing to be 0, and I would well, you're gonna end up with a division by 0, so that's probably why it didn't really work, right? And I don't really know how shaders handle the division by 0, but I just confirmed that we successfully passed a resolution into the shader. So shader is actually aware of this kind of thing. So that's pretty cool. Cool. So that means even though we have normalized coordinates, in here, right? So we have coordinates from 0 to 1. We can always convert them back into these pixel coordinates, right? It should be pretty straightforward to do that. So specifically, what do we care about? So we use Cx and Cy, and Cx and Cy is the coordinates of the current pixel. We don't really have coordinates of the current pixel. Unless we do. We can basically say that maybe X is GL frac coordinate, frac, but it will be better to actually like play by the rules and just like use frag text chord. So this is Cx. Take X and divide it by the resolution X, and in here we probably want to floor it, right, and convert it to an integer, right? So that's probably what we want to do, and we want to do the same thing with Y, right? There we go, and we have a Cx and Cy, and we can just use this entire stuff. Alright, so can I now also have emode? Right, so this is going to be the term. Emode, let's copy paste. To be fair, it would be nice to copy paste like literally everything, all of these Sigma balls and all of the other things, right? So all of that should be in here. And we probably want all of the parameters here as well, right? So the alphas and whatnot. Because all of that is kind of compatible with GLSL on the level of the syntax, so I think it's going to work. Right, so, okay. So the only thing we're missing in here is the grid. So here we have X and Y in screen coordinates, but we need to be converting them to the texture coordinates and then getting the corresponding color. So we probably need to come up with something in here. Maybe we can come up with some sort of a function, grid, which accepts X and Y as an integer, right? So X and Y as an integer. And essentially it should convert X and Y to the texture coordinates. So it's going to be more of a like Tx. So we take X, we converting that back to a float, and we divide that by resolution X, and we repeat that thing for Y as well. So, and this gives us the coordinates from 0 to 1 that you can plug into the texture 0, Tx, Ty, but I think you have to also provide it like this, right? So I think that's what you have to do. So, and that gives you some sort of a value. So it's supposed to give you this thing, right? But here is an interesting thing. It gives you the color. So texture is in reality 4 values, but the state of our cell is 1 value from 0 to 1. How do we convert color to a state of the cell of the cellular automaton? One thing we can say, we can probably take the maximum out of them. So like I don't have any proper answer. I think is just like, yeah, just like take the maximum, and that's basically gonna be the state of this thing. So it's more of like a brightness, right? So this is basically the brightness. I think it makes sense to me. Right. So furthermore, I suppose the Perlin noise that we got from the array leap just only sets, yeah, it's basically the gradient of white anyway, so they're going to be all equal to the same value anyway, right? So yeah, that's how we're going to be interpreting this entire stuff. Cool. So what else do we need in here? So in here, we're going to be doing grid x and y, right? So this is the function, and this is going to be grid x and y. There we go. So that's it. So then we plug it into S, and this is, by the way, what we have to actually return, right? So, but this is not really the final value. This is not the next value, right? This is not the next value. This is more of a diff, right? That we then need to apply to the current pixel, and the current pixel is another interesting thing. The current pixel is at grid cx cy. Right, so what we have to do div plus div, but also multiplied by dt. Did we actually copy dt? Yeah, we did copy dt, so this is basically what we have. And that should give you the value out of which you probably want to construct the color, like so. Right, I guess that's basically the entire thing, maybe? So, okay, let's give it a try. So essentially, I want to go through the compiler assisted refactoring, so probably this entire thing doesn't compile. We're going to go through the compilation errors of the shader and just like fix them as we go. My plan is going to be the following. I'm not going to switch between the frames, so it's going to be static, right? Because I don't want it to go off too quickly, right? So I just want to first fix the shader and then see if it does the animation or not, right? So we'll see how it goes. So let's try to recompile this entire thing, and of course it doesn't compile. So let's take a look at what we have in here. So there's some warning: failed to compile shader, no function exp. Okay, so that makes sense. Does JLSL even have exp? So let's actually find out. Let's actually find out. Does it have exp? I think it does. So return natural exponent of the parameter. Okay, so that means it's just basically exp, just exp. One of the things I remember, you're also not supposed to have these f's at the end of the literals. That's what I remember in GLSL, because I've been annoyed by that for quite some time. So, oh right. So what else do we have in here? So initializer type float cannot be assigned to a variable of type int. Okay, 67. 67. What do we have in here? All right. So I suppose we have to initializer of type float. So what you want from me, maybe ra and re has to be integers, right? Because they are in the pixel coordinates, in the screen coordinates anyway, so I guess it kind of makes sense for this thing to be an integer. Okay, what are the next things? So width and declare. Okay, this one is interesting. So width, right? So it is in fact in declare. And this is because we have to do something resolution. Though, maybe we need to set the wrapping mode for the texture instead. That sounds like a pretty interesting idea. Is there any wrapping modes for the textures in Raylib? Wrap. Texture wrap repeat. Maybe that's how we do that. Okay, texture wrap. So set texture wrap. Okay. I wonder if that's what we have to do. So I'm gonna put a to-do in here because I'm not sure if it's going to work. Use texture wrap mode instead. Because if we manage to use texture wrap mode instead, first of all, it's gonna be less computations in here. Less computations, and we'll be able to remove some code. We just don't need emode anymore. Right, so because, yeah, so using texture wrap instead would be actually ideal, I think. Right, so... And then here is kind of annoying because what you have to do here is just like also convert it to an integer because it's a float. Right, so yeah, we'll see. But first I want this thing to work, and it compiled. it seemed to be compiled. Right, I hope it's not... Okay, so do we have any warnings or failures or errors? I don't think so. Right, so it created successfully, default shader unloaded successfully. Everything seems to be okay. Right, so there was a big lag. Your GPU is cramped for hell. God damn. So, okay, I'm a little bit afraid. So, maybe I want to reduce some of these things in here. Right, so... Is it lagging right now? It is kind of lagging. Right, so it's not lagging. Yeah, okay, so the camera is lagging when... God damn it. Oh yeah, I can see this shit lagging. Okay. Yeah. So, all right. Let me see. So let's try to enable this thing. Okay. Let's see if we'll be able to even do something like that. It doesn't even work. Right. Right. What the fuck? Okay. So it didn't work. It didn't do anything. What if we use the Perlin noise instead? Is it going to do something useful? No, it doesn't do anything. So, let me see. Did I make any mistake in here? I actually don't think so. Do you guys see any mistakes? So, we... Oh yeah, we probably want to multiply this thing. Okay, that's a good point. Yeah, that's a good point actually. So, we want to do... Okay, just a second. So, when we're converting the... Yeah. I see what you mean. Thank you so much. Stop gaming 58. I guess that's what we had to do in here. When we do in mode. So I don't really care if it's lagging or not. If it's working, alright, I'm gonna be happy because it's gonna probably be fast when I'm not streaming, if you know what I mean, right? Right, so it's slow because I'm also streaming, because the OBS also uses my my integrated GPU for encoding and stuff like that, so I don't really have that many GPU resources anyway. Right. You can see me lagging and pogging simultaneously. That's actually kind of cool. I'm lagging and pogging. Right. That's a funny phrase. Lagging and pogging. So, okay, this is just like only one single frame, right? Right, so, and if we go to the GPU and just start switching between those things. What the fuck is it doing? Lagging. Did we F? How did we F? Like, I mean, we should be back, actually. It's not that, okay. Alright, so that was interesting. So, yeah, that's weird. Maybe this is because we were trying to do 60 FPS. Let's actually try 30 FPS. So, alright, so what about 30 FPS? So yeah, it is lagging, but it's not actually producing the things. Yeah, so it's not producing the picture I would expect it to produce, if you know what I mean. So I feel like I want to try to do the texture wrapping thing. Right, let's actually do the texture wrapping and just see how it's gonna work. Texture wrap. Yeah. So smooth life, texture wrap. So I provide state 0 texture and texture wrap repeat. Okay. So this is for the first one, and then for the second one as well. So we can even split stuff like this. So we're initializing the state 0, right? So we're also uploading the data to the state 0. And then the state 1, and we do texture repeat. So theoretically, theoretically, right, what we have to do now is just int x cx plus dx and y cy plus dy, right? So we don't need immode, which effectively means that, well, I mean, fine. Right. So, what do we have in here? What do we have in here? Maybe I need to specify this thing as float, so maybe it's converting stuff a lot. I didn't see any problems, to be fair. Right, so we didn't see any problems. Okay, so GPU. Let's not swap these things. Okay, that looks alright. What if we now keep swapping them? And it's... yeah, it's also switching around sometimes. What the hell is going on? Why is it... Wait, by the way, is it lagging? It's not as lagging as much anymore as it used to. Did you notice? That it's not lagging that much. So that means I feel like it helped a little bit. Right, I feel like it helped a little bit, but not too much. You know what I mean? It's lagging. Audio is solid. It's less like people sending me confused messages. Right, like what the fuck? Right. So some people say it's lagging. Some people say it's lagging less or something. Why is it flipping like that? I'm so confused. Like, there's no reason for it to do that? Question mark? It's just like, what? That is weird, straight up. Alright. So... So resolution X and Y. So 15 was perfect, right? So 15, let's actually see. If I do 15, right, so 15 is more or less okay, right, so with 15. Maybe it's the default shader, well, I don't know, right, how is it gonna do that? Okay. So that is weird, that is really, really weird, like, why would it start doing this kind of shit? So if we are within that thing, we're taking the grid. By the way, instead of... To be fair, we could have just like used floats in here. There's no really reason to... Yeah, there's no really reason to have this as integers, if you think about that. Right. Because we're not indexing any arrays, so to speak. All of that could be float. Like, literally all of that could be float. Right. And that stuff could be also float as well. I didn't really know. And by the way, conversion between floats and integers, like I heard that it could be kind of slow. Right. So what I'm thinking is that, yeah, so keeping all of that as integers just like not gonna help anyone. So it's just like here, I probably what I want to do, I want to just like add 1 all the time. Right, I'm adding 1. So that should actually be a little bit better. Alright, so are we like... Okay, it doesn't even compile properly. Okay, let's take a look at 66. Yeah, this has to be float. Of course, it has to be float. Alright, are we lagging? We're not really lagging that much. We're not really lagging that much, so which is nice. And if I try to start swapping between these things... Why is it flickering like that? This is so weird. So it's just so weird. Like, there's no reason for it to flicker. Huh. So let me maybe try the following thing. Frag, so texture 0, frag texture coordinates, Right, and let me see, can we see the original texture? Do you guys see it's flickering? Right. So, are you sure you meant 1 - E for begin texture mode? Yeah, that's what I meant, to be fair. Right, because it's 0, so it needs to be rendering into 1. Try to disable repeat. You think it's because of the repeats? No, it's not because of the repeat. It's something else. I feel like coordinate related. Sure, but here I don't really modify anything. So frag text coordinate. Right, I just don't modify anything. I can disable this entire code. So this is the original vanilla shader that we used. That actually we confirmed that it works, by the way. Right, we confirmed that this thing worked. This is literally what we did. And it was not flickering. You need to apply the swapped texture to texture 0 slot. Swapped texture to texture 0 slot. I don't know what that means. But I kind of understand what it means in terms of OpenGL. But I don't understand what it means in terms of raylib. So that means that the OpenGL kind of leaks through raylib. Yeah, it feels like a Y is getting inverted every frame. It would be kind of nice if raylib didn't try to mess with the coordinate system and just like used as whatever OpenGL used, because... Okay. So I suppose it could be because I have a custom shader. And the custom shader doesn't do the thing that the default shader does to map the coordinates or something like that. Is that what's going on? It kind of doesn't help. It makes things more complicated. If the intent in the raylib was to make things like easier to understand, it didn't really work out. Okay, so let me try to take a look at some of the examples. All right. So let me think. So there was a fog of war. All right, so we have a fog, and let me take a look at the fragment shaders. So this is the shaders, GLSL, fog. So there was just like fog, GLSL. Okay. How do we, so there's a light, there's this kind of stuff, so the texture, so we're just like using, but the weirdest thing, like, okay, stop. The thing that I did in here worked. It did work. It did freaking work. So that means there's something, no, it's not like the coordinates are messed up. This thing worked. It stopped working recently. No. You're not gonna gaslight me like that, chat. It worked before, and then it stopped working. Because I specifically checked all of that. Right. Yes. It worked, but at the same time, there was a warning in here, right? So there was this kind of thing. Okay. So right, if I just do something like this, right, it goes into an opposite thing, right? So I'm rendering the current thing into the back thing. That's what I do. Into the back thing. And then I'm rendering this one more time, and then I'm swapping it. But I can actually kind of swap it like this, right? I can swap it like this and just render it like that. So yeah. And now it works. Huh. And now, if I... Well, I mean... Because that's what it has to be. Yeah. So, there is something with texture slots. Somebody mentioned texture slots. And this is actually a very interesting idea. So there must be something with texture slots, but I'm not sure what exactly. Right, is there something with texture slots? No, there's nothing like that. So texture 0. Draw texture. Something extremely weird going on, and I don't really know why. So I need more examples on how you work with textures and whatnot. Let me see. Maybe more examples for render textures, right? So render texture 2D. Alright, so hybrid renderer. So this one sounds interesting. Load texture, right? So there's a target. So there's a camera, target, blah blah blah. Texture mode. Okay, so we're just doing that. Alright, so and then we're just drawing target texture. But there's nothing like that. So unload render texture depth texture. Right, so Fabio HBF, thank you so much for tier 1 subscription with the message Sodin cool indeed. Alright. It feels like something with the RayLib. It feels like this abstraction is leaking, right? It feels like this abstraction is leaking somehow. Yeah, so like what is going on? So is there any examples when you have several render texture to this? Right. I feel like no, right? Because yeah, unload. Yeah. Attachment. Okay, so there is this thing. Okay, there is a direct working with texture attachment and stuff like that, which is a little bit painful, right? Because I specifically picked RayLib so I don't have to do this kind of stuff. Not really big fan if I have to do this kind of stuff. It's just like, no, I specifically use RayLib so I don't want to do that stuff. Thank you very much. If I have to do this kind of stuff, I might as well just ditch RayLib. Right, so... So there's a hybrid Julia set. Maybe Julia set is something that we can use in here. I'm getting disappointed at RayLib if this is what I have to do. So I really don't see what's going on. What's wrong? Right, so unless it's something within RayLib, really, unless it's something within RayLib. Maybe try copying the texture by update texture and some kind of read texture. Seriously? You are suggesting to send data over CPU, like defeating the whole point? I might as well like not use OpenGL then. Alright, what's the point of using OpenGL then? Right, you suggested like, yeah, that just ditch OpenGL. What? Oh, okay, so there is this kind of thing. Yeah, just like send the data and copy it on the CPU and just like... Seriously? Alright, this one is actually kind of good. Thank you so much. Somebody actually sending useful messages. Alright. All textures in OpenGL by default have origin in the lower left corner, while the screen origin is by default when you load normal. Okay, where is this? The solution that you're... What? Oh, how is that? But how does it solve our problem? Our problem is not that it's flipped, but it keeps flipping. It's not because it's flipped per se, it's because it keeps flipping. Right. If it's just flipped once, it's gonna just stay flipped, but it's not gonna do that on every frame. There's a subtle difference between coordinates just being constantly flipped and flipping on each frame. Right. So if thing is just flipped, I can just think in different coordinates and that solves the problem. Why it keeps flipping? That's the problem. And maybe that is actually a very good point, to be fair, because we're feeding... Okay, so that's actually a very good point. Maybe what we have to do, is flip it in here. Right, what if I just do it like that then? No, it didn't solve the problem. But maybe ray leap. It's just like if you didn't mess with the coordinates, maybe this would not be a problem. Oh, yikes, 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 yikes. It's just like, it creates more problem than it solves. Like, seriously. And... This is so painful, dude. Like, why do I have to... Wait a second. I forgot to enable this thing. Wait a second. Okay. So yeah, I was working with a different thing. Okay. So that should be fine. So that means... okay, so I need to disable... but maybe it's not a ray leap problem. Right, it's just like inconsistency of the coordinates of OpenGL. It's just like, I don't know, I want to blame somebody. I'm so disappointed that I have to deal with this kind of shit that I want to blame somebody. Right, I just like really want to blame somebody, and I have to blame either Ray leap or OpenGL, so I need to pick one. Who should I blame? I cannot blame myself, obviously. I did everything right, but somebody screwed things up. It's either Ray leap or OpenGL. Okay, that's a very good point. That's a very good point. Okay, so I think I now understand what the hell is going on. Alright, so blame chat. Oh, yeah, that's actually a good target, so I think I'm gonna blame chat. Thank you so much. Thank you so much, chat, for allowing me to blame you. Alright, so... because I really need that. Right, so nothing works, and I want to blame somebody for that. Right. Okay, so essentially, what we want to do in here, right, so we want to invert this... Yeah, so, and the reason why it flips around is because we feeding it into like its own loop, right? So we keep feeding it into itself and it just like flip-flops, and I finally understand why it's doing all of that. So yeah, thank you. I'm sorry for being ranted today, I just need to blame somebody. So, well, I mean, it didn't compile. At least it didn't compile, so we can forgive it that. 82, yeah, what the hell is going on in here, bro? So yeah, this is basically what I want you to do, right? So, all right, at least it's not flipping around, but it's very squarish, if you know what I mean. Right. So, is it lagging? It's not really lagging, but it's actually doing something. Right. So at least it's doing something. So we're doing wrap repeat, so that should work out, okay. So that's pretty poggers, But why is it so squarish, if you know what I mean? Why is it so squarish? That's the real question. So one of the things we can maybe do, we can try to get rid of the m's and n's, right, by essentially computing the areas of the circle, right? So what's the area of the circle? Area of circle. I don't remember school math. Thank you so much. So area, circumference. Oh, who needs circumference? So that's the thing. So it's basically pi r2. So of course, I mean, it's a square, right? So it is square. So we have a pi, right? So give me the pi, boy. Give me the pi. Oh, okay. So here's the pi. This is, what is this pi? Give me the bigger pi. Google. There we go. That's the proper pi. Right, I think GLSL doesn't have a pi, right? So you literally have to define it yourself, right? So this is going to be the pi. So what I want to do, right, so M is the inner circle, right? So it's an inner circle, so that means it's pi multiplied by Ri. So this one is actually rather interesting. So it's an outer circle, right? So if M is the inner one, this one is the outer one, right? But it's an area that excludes the inner one, so we have to do something like minus M. Right, and that way we can do something like this. Right, we can effectively do something like this and then divide by these things. Right, so I wonder if that's gonna fix something, right? I wonder. Right, so this is gonna be float. So let's see. Maybe this is because of the floors. Because everything is so smooth, maybe we don't really have to floor anything. Maybe that's another thing that I don't have to do in here. Right, do we have E-mode? E-mode. I'm gonna just disable this thing for now. Right, so that reduces the amount of codes, like at all. That worked out, I think? Yo, what the fuck, it worked out. Holy shit, it worked out. I just had to make everything smooth. That's it. That was the problem. All right. Okay. So we're onto something, chat. We're onto something. Let's make this white noisy. Let's make it white noisy. And it died. It literally died. What the fuck? Okay. So the radius is actually kind of nah. Maybe it's too fast. What if I make it smaller? Why is it dying? It's just like, yeah. It's like, whatever, I guess. It's kind of funny. But this one is like, it exhibits like behavior of the smooth life, if you know what I mean. It does look like this thing. I actually slowed down the DT. I slowed down the DT, but the DT has to be like around, yeah. So what is the FPS in here? The FPS is 15, so we can just basically divide that thing by 15, right? So that's the basically FPS. So it should go faster. So it kind of like moves. It kind of moves, but at the same time it's just like, yeah, fills up everything. Clearly a maze generator. Well, yeah, if we take a look at whatever we had here, right, so it's kind of similar. So terminal, right. It generates similar structures, right? So if you let it run for a little bit, it will essentially create a maze as well. Right, it will essentially create a maze as well. So maybe we should also initialize that thing with a specific region or something like that. Right. So, and at some point you will see that it will generate these streaks. Does it sound, does it look familiar? Right. So the same model kind of like generated that. So that means we are on the right track, right? So because here it generated similar streaks, as you can see, right? It generated similar streaks, but it didn't start like creating like, you know, alive things, if you know what I mean, right? It didn't start creating alive things, unfortunately. So, but this is the Perlin noise. What about cellular? There's also one thing that I want you to try, by the way. Yo, that's so cool. The fuck? Right. So that's actually super cool. And it just fills up this thing down there, right? Kind of. Right. So remember how I was so confuzzled about alpha, like two alphas mentioned in the paper, right? So essentially here, right? They never actually mentioned alpha n and alpha m anywhere, and then they suddenly said, as we have two different types of steps, we have alpha n and alpha m, and that's it. And they never actually mentioned it in any of the formulas in here. They never explained how you're supposed to use alpha n and alpha m. It's just like, oh yeah, obviously you have alpha n and alpha m. And by the way, to achieve cool result, you have to set them to here. But how do you use them? They're never mentioned in any of the freaking formulas. It's just like, what the fuck? Like, I went through the entire paper several times and just like, what the fuck are you talking? What are you smoking? What are you smoking? There's no alpha n and alpha m. I was thinking about that, chat. I think I fucking figured it out. So I'm gonna show you. Right. I tried to smoke the same thing as the author of this paper, and I think I understood what they were trying to say. Right. So you need to actually draw these formulas. So basically we have a bunch of things here depending on each other. Right, so these things, these sort of functions, they depend on each other. You need to draw the dependency. That's the key. I'm going to show you. You must draw the dependencies. It's so dumb. Okay, you're going to see that. All right, so I think I want to close this thing. Right, so first, what do we have in here? We have s, which is function s. Right, so this is a function s. What does it depend on? It depends on two functions. It depends on sigma 2 and sigma m. Right, so let's actually do sigma 2. So this is a sigma 2, and this is the sigma m. Right, and we literally draw the dependency graph of the functions. Right, so the function s depends on sigma 2 and sigma m. Makes sense. Sigma 2 depends on sigma 1, right? So we can say that here is the sigma 1, right? So this is the sigma 1. So sigma 2 depends on sigma 1. And sigma m here, you can see it depends on sigma 1, right? So these four functions, they form this sort of diamond. And sigma 1 already depends on an unnamed alpha. Right, it depends on an unnamed alpha. So this is basically the dependency graph. And look at a very interesting thing. So sigma s, well, specifically s, accepts two parameters, n and m, right? So you have n, right? You have n and you have m, right? And you feed those parameters into the s. And look how s redistributes the parameters. N goes into sigma 2, so n goes into sigma 2, and m goes into sigma m. Right. So, but then these two parameters go into sigma 1. So that means that the sigma 1 that is used by sigma 2 has to use alpha n, and sigma 1 that is used by sigma m has to use alpha m. So it would make more sense if that alpha was just the parameter of sigma 1 and sigma 2 was just called sigma n. What the hell is wrong with these people? Like, why did you have to do it like that? Like, if you just draw it out like that, it kind of makes sense. Like, but why do you have to make it so cryptic? Like, why don't you make alpha the parameter? You just make alpha the parameter, you get rid of the sigma 2, you call it sigma n and sigma m, and since you only have one sort of like sigma, you can remove these things. So you can just say, this is a pure vanilla sigma, this is the sigma n, and this is the sigma, like, it's just like, So there is obviously a cultural problem in here. In our coding culture, if you write a shady code, you're gonna be humiliated immediately, right? You're gonna be humiliated immediately, right? If instead of just doing something like if true, return, like if x, return true, else return false, you do something like that, you're gonna be instantly humiliated because what you're supposed to do, you're just supposed to do return x. In mathematical world, apparently, whatever you write using this beautiful, beautiful font is already beautiful by itself. So these people go absolutely unchecked. They write shitty formulas and they go absolutely unchecked, and everyone thinks that they write beautiful things. I think we need to bring that culture, this programming culture, into the math. and keep these people in check so they don't write shady math. You know what I'm talking? I'm joking, by the way. Right. I feel like there's no such culture in mathematical world, right? So the power of later, you just use a fancy font and it looks beautiful. So obviously I'm joking. Right? So we need to start bullying mathematicians. Don't bully anyone. Please don't bully anyone. Right. Okay, so I think that was the intent, at least. It was written in a very cryptic way, but I feel like that was an intent. Right, and what I'm thinking is that maybe if we just code this entire thing like that, maybe then it will work? Maybe? We'll see. Okay, so let's actually give it a try. So I'm gonna bring this stuff like so. Okay, so where is my paper? So alpha n is 28, right? So alpha n is 28, so this is alpha n, right? And this is alpha m. I'm gonna fix the terminal version. People from machine learning are also famous to make hard to review code. Well, I mean, this is basically job security. Okay, so what I want to do, I want to go to sigma 1 and I want to accept the alpha like this in here, right? So this is going to be alpha, and I'm gonna literally rename sigma 2 to sigma n, right? And sigma m, maybe I'm gonna also underscore it so it's a little bit easier to read. Right, so, and since it's sigma n, right, I'm gonna be passing alpha n in here, right? So this is gonna be alpha n, and since this is sigma m, I'm gonna be passing alpha m in here. And now it makes perfect sense in here. It's just like, yo, bruh, that just makes sense. And it's just like so beautiful. Like you have sigma n, you pass n in there, you have sigma m, you pass m in there, and they use corresponding alphas, and it's just like, it makes sense. Like this is what should be written in the paper in the first place, in my opinion. All right, so yeah, that just makes perfect sense. At least, like, I don't know if it works, but we'll see. So let me try to build this entire stuff. So just a second. We're not gonna run anything. We're gonna just like rebuild. Okay, so it's complaining. So sigma 1. So this has to be, yeah. Makes sense. Okay, it's working. So let's take a look if these parameters produce something. That is cool. Well, I mean, it's more interesting. You saw the pulsar. Did you see the pulsar? It's like, well, I mean, it didn't break it at least. Yo, it's kind of more alive in some sense. Well, it still like converges to this stable state, but I think it was a little bit more interesting. Sometimes it dies out, but all right. So, okay. It's a little better, but I don't think it's that much of a difference. And it still converges to this thing. It's breathing. You can see how it's breathing. It's kind of cool, like these sort of like things. Oh, look! It's actually moving. I feel like it's more alive than the previous version. Yeah, it's breathing. It's actually alive. Kill it. I already killed it, don't worry. Okay, so let's actually try to use this in the shader, right? So maybe that will make the shader more interesting. Who freaking knows? I don't freaking know. Right, so let's bring the parameters there. So maybe it's gonna do something. I'm gonna keep the DT the same, right? So this is gonna be that. And let's change the the sigma stuff, the transition thingy. Right, here is the transition thingy. So we're using a different transition now. Okay, so we're gonna rebuild everything, and let's just try to run the GPU stuff. I should have actually run it right away. Smooth the GPU, and okay, it didn't compile, that's why it was flipping around. So EXPF, okay, so that's... Okay, I need to fix all of the mistakes here again. God damn it. Right, so this has to be that. Do we have anything else? By the way, I think I forgot something important. Aren't you supposed to also clamp this shit? Yo, what the fuck? In the original term, we were clamping that. Do we clamp anything in here? We don't clamp it. This is important, chat. This is important. So there was 0.5? Where? Okay, yeah. I mean, the compiler will tell me. So, do we have clamp in GLSL? So I think clamp is... Okay, so there is clamp. So what are the parameters? Okay, so minimum and maximum are the second and third arguments. Okay, so we can just do something like clamp 0, 1. So clamping is, yeah, it's a very important thing. Okay, so can we now try to run this entire thing? Freaking 24. So DT, okay, so I just redefined this entire thing. That's it's starting doing something here, but I'm not sure if it's going to... It just goes into very stable state, which I'm not really a huge fan of. Right, I'm not a super huge fan of. Right, so let me try a different thing now. GPU. So what about Perlin noise? So not a cellular one. So all of these things result in a very stable structures. It kind of works, but it's not what I want. Right, so this is definitely not what I want. And it kind of behaves like what I want. White noise. Maybe it should be more dense, if you know what I mean. Right, maybe it should be more dense. Let's try white noise. It just falls into a very stable state that I'm not a huge fan of. I want this thing to be alive, but it's not, it doesn't want to be alive. Ra is different. So maybe we should like initialize our own thing, right? But let's go ahead and initialize our own thing. So I'm gonna basically do image gen image color, right? So gen image color, and oh, by the way, what we're supposed to initialize this with, I think it's like things from 0 to 1. That would make even more sense, I suppose. But anyway, so gen color, screen width, screen height, and black, right? So this is going to be black. But the thing I want to do now, I want to iterate. Actually, let's start with the integer. So it's going to be y less than screen height, and it's going to be 4th. All right, so then it's going to be x width x, and for each of these things, so in arraylib set what is that, draw pixel something texture, or maybe image draw, yeah, image draw pixel, yeah, I remember that. All right, so image draw pixel. And that is going to be basically X and Y, and the destination is going to be that specific image, but the color is very interesting. So we can basically say that we're going to have something like this, but the V is going to be some sort of like a Q, but multiplied by 255, right? So something like this. And the Q is going to be, we might as well actually do something like rand float, and we can copy paste rand float from here, right? So it doesn't have that. So image, uint, it wants integer, this has to be a pointer. All right, and it just keeps growing. It's not really producing anything interesting per se, it just keeps growing. Maybe this is because of the parameters, because I simplified the shader as much as I could, actually, if you think about it. I simplified it as much as I could. And what if I remove this -1? Is that something we can actually do? Is that a good idea? It's just growing, but I mean, it kind of behaves like the original thing, but it doesn't separate, right? It's too stable. That's what I would say. It's kind of too stable. It's kind of too stable. It just generates this sort of, you know, mazes and stuff like that. But maybe this is because of the parameters that we're using here. Maybe this is because of the parameters. So if we set the dt like so. What if I make dt even faster? Maybe it will be less stable. Okay, finally! It's doing some... Okay, so I should have actually made it faster. So it's doing something interesting. Okay. That was cool. Did you see that? Did you freaking see that? It did a thing. Alright, so I think I need to... Okay, I need to increase the DT for this specific thing to actually make it do interesting stuff. What about like 8? I think I found it. Yo, yes. Okay. And it still like goes to this stable state. Alright. What about like literally 1? Let's make it 1. Okay. So in that specific case, we can actually use noises and stuff like that. Perlin noise. Alright. So there we go. Continuous game of life, everyone. Actual continuous game of life. Yo, what the fuck? I think, yeah, so essentially it was too slow. It's so cool, it creates these gliders that only... Yo, this is an epic win. Okay, so that was the goal of today's stream, actually. That is so freaking cool. Look at that. Look at this shit go. What the fuck? Oh my god, and it keeps going. That's exactly what I wanted to achieve when I started this entire project. Oh my god, that's what I wanted to see. What the fuck? It's so cool. Holy shit. Yo, what the fuck? What if I make it, like, I'm afraid to make the radius even bigger. I feel like the sizes of these gliders actually very much depend on the radius, on our A. Right, if you give it more, they become kind of bigger. Right, we can try to make it like 17. 21 would have been ideal, but it's gonna be too slow. Yeah, you see, they're bigger, but it's just slower. Right, you can keep increasing the radius. If you make the radius bigger, it just like means that it has to consider bigger neighborhood. Right. So we can't really change the radius that much, but we can try to change the size of the window. That's a good idea. Somebody suggested. All right. So let's give it a try. We can try something like 16. Right. Factor by 9. Right, and we can say, okay, so the factor is going to be 18. Alright, so that's basically the thing. So it needs to generate the pertinent noise. Alright, so it's doing things. I hope it's gonna actually get bigger at some point and it goes somewhere. But yeah, so the sizes of the gliders kind of stay the same. And so it just like goes on the side, so I don't think it's that great. Interestingly, by the way, we can make it think. We can actually make it think that it's working on a smaller window. If we multiply the width and height by a half, it will literally think that it has a smaller window. Yo. I mean, that is fucking dreamy. Like, what the hell is going on? Why it is like that? That is weird. Right, I was expecting it's... Oh, I think I know what the fuck is going on, right? No. They're overlapping, but I don't know why would they think they are overlapped? Because it's just supposed to just scale the entire thing. What if I multiply it by 2 in here? Will it change anything? Yeah, it's kind of weird. So it probably something weird. Yeah, but this is cool. It would be kind of nice to like make it bigger, right? But yeah, it's so cool. Holy shit. Alright, so let me see what I can do. So we're using resolution in here, right? So we're using resolution, and so essentially that's what we do. So yeah, just by making the resolution smaller, it should make it think that, yeah, so that should effectively work, but it doesn't. And I'm not really sure why. I'm really not sure why. Because when we're accessing the grid, we are dividing that little thing by x. But yeah. So if we had this sort of like a scalar, right? Resolution, scalar, resolution, scalar, and then just half, or maybe 75. I cannot explain this overlapping behavior thing, especially when I do half. Like, I literally cannot explain it. Why would it behave like that? Is it because of the wrap? I don't think so. I don't think it's because of the wrap, because we're just like mapping. I think I can explain that. Yeah, okay. Yeah, I see what's going on here. Yeah. So, essentially, to make it work, we have to set a rectangle. So yeah, essentially what I'm doing, I just like setting the bigger pixel. Okay, so one of the things I can do in that case, I can just like have a smaller texture, a texture smaller than the window. Right, and then just scale it up. One of the things I can do. So in that case, by the way, I think it would be nice to maybe use floats in here. It's going to be converted to integers anyway, so who cares? So texture width, right? So texture width is going to be screen width, but let's say it's going to be half of that. Right? So texture height, height. So we create the window over the screen width and height. But for the image, we're generating a texture like this. So, and it would make sense to actually have a scalar, which is going to be half of that, right? Because we're going to be using that to scale this thing. So this is the scalar. All right, so this is the texture. So in here, I need to replace screen with texture. Boom. Okay. So here we load the texture, so it has to be like through the entirety of this thing. I think screen and texture, yeah, they should be replaced. So, and when we're rendering the texture, draw texture, one of these things support the scale. They do support scale. So if we do something like this, so we can provide the state I texture. We can provide the position, which is going to be, so this is one of the times when I need to use Clearal vector 2, 0. Rotation is going to be 0. Scalar, we have to do the opposite of the scalar. So so I need to scale it twice. So that means if I do the invert of the scalar, right, if I do 1 over 5, okay, so that's perfect actually, that's exactly what I want. And the tint is going to be white, right? So yeah, essentially I just like make the texture smaller, but then I scale it up. And on top of that, we may want to set different interpolations in there, like, so by default, I think it's going to be using bilinear interpolation, so it's going to smooth things out anyway, so it's not going to be pixelated, hopefully. Right, so that's actually a cool idea, I think. All right, let's go. That's much better, so you can see it much better now. We can keep scaling this thing up. We can say it's 0.3, and we can see these things even better now. That's actually really cool. They're slightly pixelated, but wait, it doesn't use bilinear interpolation. Okay, so let's actually set bilinear interpolation. Relip, bilinear interpolation, texture in. How do you do texture interpolation one more time? Does anyone remember? Set texture filter. Okay, so this is a filter. Okay, so filter, shader lock, texture filter. Okay, so bilinear. This is what we need in here, chat. This is what we need. So I can set the texture rip. I can also set texture filter. Right, so we're setting these things. Texture filter bilinear. Right, there we go. So we're making it wrapping around, we're making it bilinear. And wrapping around the texture, I still think it's kind of important. Right, so does it look smooth? That looks much smoother now. We can make it like, you know, 16 by 9 as we initially had. 16 factor. Float factor. And let's make it maybe even 100, so it looks nice and all. Is it gonna look good? Is it gonna look Gucci? It's gonna look Atamaguchi, chat. How do you like them gliders? And they all died. Right. So yeah, they don't have that much like interaction with each other. So yeah, let's try different initialization. So this is a Perlin noise. What about white noise now? So maybe white noise is going to work out. White noise didn't work out, so I think it has to be a little bit denser. Did it work out? I think it literally died. All right, so if I do it, like it instantly dies, unfortunately. So cellular. What about cellular? It's a little bit better, I think. We can use cellular. So this is the smooth life. It's as smooth as you can get. One of the interesting thing would be able to draw on this thing. So I click on this thing and it maybe creates a circle. But how can you draw on that thing? I don't really know. Yeah, they kind of feel like metaballs, but they're not really metaballs. these gliders don't really survive for too long. Holy shit, what the fuck is going on? They look like bubbles, right? They pop in like bubbles and stuff like that. You coded metaballs? Nice. Yeah, metaballs are actually super fun. Yeah, level up. That's so cool. And what's interesting is that it does look like an original discrete Game of Life, but continuous. Right. It's just like it's continuous, but it has the same sort of like behavior of the things. It's just so weird that it's just like it behaves similarly. No more lagging. Well, I mean, we reduced the resolutions and stuff like that, and we just like adjusted everything so it doesn't lag that much. Honestly, I would love to maybe make the bigger radius, but I feel like the bigger radius is gonna just like make it laggish again. No, really, actually, if you look at that. It's a bit laggish, but at least they are bigger now. Right. Yeah, that's cool. They're not really gliders, they split and die. Yeah, though we could have adjusted some of the parameters in here, right? So maybe I could adjust this thing to be 68. I don't know how sensitive it is to the parameters in here. Is it really sensitive? Well, I feel like it is sensitive. Okay. So let's not do that. So I know on the Shader Toys, there is a similar implementation. Okay, so Shader Toy Smooth Life. So, and it has some parameters that maybe we can steal from it, right? So we can try to steal some parameters from this thing. Unfortunately, the problem with Shader Toys is that it kills my setup when I'm streaming. So I'm really hesitant to run this thing. Okay, so I paused it. So this thing has some parameters that we can yoink. So specifically B1, B2, D1, D2. Right, so Smooth Life L. Right, so it's specifically Smooth Life L rules. And they're kind of different from what is in the original paper. We're using parameters from the paper though, right? So, and what about the radii? Does it set the radius, radius something? It's using radius in a really weird way. I don't know how it's using them. I don't know, whatever. So I'm gonna just use these parameters. So it's probably not gonna act the same, right? It's probably not gonna act the same. Const, huh? So I'm gonna put this thing in here. As you can see, they are slightly different, right? So remove the stuff. Specifically, the death and birth intervals, they're different. They're slightly different. Stolen from this thing. Right, so this is going to be 257. Okay, so let's see if it's going to change anything. Make it interesting, more interesting maybe. Alright. So let's go. It creates really weird creatures actually. Like, look at that. Those gliders are so creepy. Like, what the fuck? Yeah. I think I like this original one, so it's probably coded slightly differently. Yeah, so that's basically the result of today's stream. Right, it's not particularly stable, but when it becomes stable, it's actually kind of cool. It just like keeps going and doing things. Right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreational programming session. So yeah, that's pretty cool. I love you all. Mwah.